The continuous evolution of modern quality management methods demands not only high efficiency and accuracy in product dimensional inspection, but also increasing importance on traceability. In this issue, we will visit Huaying Mold to explore how high-precision 3D scanning helps achieve a traceable scientific quality inspection model. Huaying Molding is a lost foam manufacturer. The dimensions and shape of the lost foam, which is the first step in mold production, will directly affect the quality of the finished products from subsequent casting and machining processes. To better conduct inspection of product dimensions and shapes, Huaying Mold started collaborating with Xianlin Tianyuan in 2017 and has consistently trusted Xianlin Tianyuan to upgrade scanning equipment during this collaboration. Now, the engineers are conducting a quality inspection of a lost foam model, first using the FreeScan Trak Pro2 laser tracking scanning system for data acquisition. For this 4-meter-long lost foam model, the scanning time takes only about 10 minutes. The scanning process does not require sticking points, reducing the time needed for attaching and removing markers by an hour, which is very efficient. After the scanning is completed, in the inspection software, you can directly compare it with the design data through a color map to visually check if there are any shape deficiencies and whether the dimensions are within the required range.
This thing allows us to quickly discover that when we perform final product size inspections, some issues come up, like missing materials due to incomplete adhesion, which can be seen very intuitively. If you rely on conventional inspections, you might miss these issues because, having seen it many times, you get accustomed to it.
When the inspection is completed, the original data of the scanned lost foam, along with the inspection report, will be archived. This allows for traceable quality management that can be retrieved anytime needed. Using high-precision 3-dimensional scanning to create a traceable scientific quality inspection method has significantly reduced quality and management costs for Huaying Molds, while also holding important significance in upstream and downstream cooperation.
Before, it was all manual inspection, using a tape measure to measure manually. There might be a report written, or sometimes we didn't even write a report. Back then, the control wasn't so strict. But as customer demands increased and product quality control requirements grew stricter, different methods had to be used for control. With manual inspection, someone could measure on their own, and you couldn't control that.
Through technology replacing manual traditional measurements, Huaying Mold has achieved a standardized inspection method, preventing defective products from leaving and significantly improving product quality. At the same time, creating a traceable quality management method is also very important in the cooperation between Huaying and downstream enterprises.
The most crucial aspect is traceability, because after I scan, I have a point cloud data model that I can retain. I might keep it for a year, and if the client says there is a problem, I can directly provide them with the original data. There are many production processes, so there are a lot of disputes. If you don't manage it well, the losses could be significant.
Based on high-precision 3-dimensional scanning technology, the traceable scientific quality inspection model not only enables fast and accurate product dimensional quality inspection, but more importantly, it can achieve one-to-one restoration of product dimensions in 3-dimensional data archiving, realizing traceable quality management. After years of cooperation, Huaying Mold has improved the efficiency and reliability of product dimension inspection and developed a scientific management approach to enhance operational efficiency. Next, Xianlin Tianyuan will continue to provide support and become an important technical support force for the successful operation of Huaying Mold.